Hey there, welcome to this lecture. Today, we are not here to learn Kubernetes by memorizing YAML or kubectl commands. We are here to learn how Kubernetes fail in real life and more importantly, how DevOps engineers deal with those errors without losing the patience. Because this is an essential skill for DevOps engineer. And believe me, if you are supporting Kubernetes in production, this is an essential skill that you must have. Let me tell you, what you are about to see is not a toy example. This is a realistic system where everything looks healthy, yet the application does not behave the way we expect. Before we break anything, let's quickly understand what we have deployed so you know exactly what system you are debugging. We start with two namespaces. One namespace is for application and another one is for the database. I have tried to replicate the real world scenario. You do not want to put everything in one namespace, right? There may be a different team that is owning the database and they will have their own namespace, right? So that's what I have tried to mimic here. Then we have this config map. This config map contains our entire application code, a simple fast API application. The app exposes one endpoint slash, which is the root, and its only job is to tell us whether it can connect to the database or not. Just to make it look cool, I have added some HTML and CSS, but if you are not into this, you don't have to worry about this script at all. Just let me minimize it. For you, there is some Python code kept inside this config map that we can mount and make it available to our application pod, right? That's all it is. Okay, and here is the deployment of our database. We are using Postgres 16. I believe the latest version is available, but this is fine. This works for us. These are some arguments we are passing, and this basically runs our database. Then because it is running, we need to expose it somehow. Then we are using this Kubernetes service for exposing the database over port number 5432. This works. And then we are working on the application deployment where the config map that we just discussed is mounted as application code, and then deployment takes charge of running that application code because this is the working directory and application will be using this image. So basically UVCon will take care of running the application code on the server. It's very simple design, right? We all have seen it 1,000 times. And then lastly, we are exposing the application using this so that the beautiful UI for which we have written the application code in the config map can become live in the browser. Now, this is the Kubernetes challenge. So as usual, we have kept three files. This is the challenge where you do not get any help in fixing the issues. Then we have guided where there are some error messages to guide you towards the error. And then there is solution in which there is no error introduced, and when you apply it, you get to see the application 100% functional, right? Okay, now it's about solving the challenge. So we need to go to the terminal and let me list the namespaces. Okay. In this list of namespaces, you do not see black hole DB or black hole application. So very clearly, none of our application component is working till now. So whatever going to happen in rest of the lecture is going to happen in front of your eyes. That's the point. Okay, kubectl apply -f 01 challenge.yaml. Yes, that is my file. Let me apply it. Very good. Things are. So let's see what is there in the black hole DB first. Let me take the full screen also for this. Okay, so the database is running, service is there, there is no external IP for it, deployment app, it's all good, right? Perfectly fine. And this is a dream of a DevOps engineer to see everything working in the first go. Very good. Now let's see what is there in the app. Here also pod is running, service is live, it has got an external IP, deployment, everything is good, right? I'm sure config map is also there because that's how the pod is running, right? So yep, application code config map is created as well. Pretty good. Let's take the external IP and hit it in the browser. This is the IP and this is my browser. Let me paste it here and hit enter. So you can see it is scrolling, but we are not getting any response. Means I'm wondering whether the traffic is actually reaching the application or no. So what I can do is see the logs. Yeah. So logs, this is the application pod. As we can see, the application was started, but after that we have not received a single request till now. This is the last message. Let's give it one more try. For some reason, if it is not reaching, let's see if further request goes. So I'll just follow the logs and hit enter. Nope. So it is scrolling in the browser, but traffic is not reaching the application. So my application is harmless. You cannot say that, it's the application which is not giving the response or there is some issue with the application. That's not for sure. The traffic is never reaching it only. But I have every reason to doubt the browser. Maybe there is something wrong in the browser. It's some wrong IP is cached or something like that. That's why it is not going out. So a good intelligent DevOps engineer will always do one thing. Instead of simply, saw some error and start doing 100 things without understanding what is going on, what a good DevOps engineer should do is take a systematic approach. I'm using Windows, so I have got Test-NetConnection in PowerShell. If you are on Mac or Linux, you'll use Telnet here. So just use this, give the IP address to which we want to connect with and the port number, right? Over what port you want to connect. Now, what is the port number I should specify? Well, just take a look at the application service port. So this is my application service port over which we are trying to reach the application. It's port number 80. So we'll just say port 80 and see whether we are able to reach the application over this port or no. Okay, it's performing ping ICMP test. Pretty good. Waiting for the reply. And look at this. The reply is failed. Ping did not succeed. Means the browser cannot be doubted anymore. Genuinely we tried to reach this IP address over port 80 and it did not work, right? So then what should I do is look at the service more carefully. So this is the service. We are sending the traffic to it over port number 80 and expecting that it will hit the application at port number 8080. Let's go to the deployment. Okay, this is my container and look at this. This is the problem, right? Container is exposing the application over port 8000 as well as the application is running within the container on port number 8000, 8000, right? But we are trying to send the traffic over port 8080. Basically, our service is knocking on the wrong door. Good analogy, right? Okay. So fix is going to be very easy. We need to send the traffic to the same port which is exposed. So it has to be 8000. Very good. Let's apply the manifest one more time. And you can see the application service is updated accordingly. So let's do this test net connection one more time, because now we have corrected the port. And there we go. As soon as we have corrected the port for the application service, now TCP test is passing, which was clearly failing earlier. Means it is good idea to try it one more time in the browser. I'll say in the new tab. Not over HTTPS, but HTTP only. And there we go. The application is loading perfectly fine. Kubernetes connectivity demo. It could not translate host name DB backend to address. Name or service not known. Okay. So my application is not able to connect to the backend database. That is clearly an issue, but main application is loading perfectly fine, right? This is my current reality. So this service is perfectly fine. Let me minimize it. As well as the backend application is loading fine. It is trying to connect to the database backend. It is failing to do so, and it is not able to connect to the database, right? That's where we are right now. Why we are not able to connect to the database? We need to look. Now I want you to answer this. From where we are trying to connect to the database? Is it from my system or it is from the pod running in Kubernetes cluster with this name and this namespace? Clearly, and no doubts you know it, that we are trying to reach the database from this pod. not in my system. Is it a good idea to do telnet and test the connectivity to database from my system? No, it's not a good idea, because even if it is allowed or not allowed, it doesn't bother the application at all. What is important is, are we able to reach the database from the system or the container where the application is hosted, right? So for this reason, without wasting any time, what we should do is go to the application pod. What is the pod? This is the pod. Okay, we need to take control of this pod. Means what we need to do is take a interactive control of the terminal of this pod and run commands from there to see whether we are able to reach the database or no. That's what we want to do, right? So this is the command exec -it. We want interactive terminal, the pod name, and what is the command that we want to execute? Maybe sh. That's the command. Yep. Hit enter. And the moment we have done this, we have got the control of terminal of this particular pod. You don't believe me? Let me do host name. What it is supposed to print? The name of the current host. Correct? So it is this. This is nothing but the pod name. Okay. Pretty good. Let's see whether the curl command is available inside this. Okay, curl is not there. Let me see if the telnet is available. Okay, even telnet is not available. NC? This is very bad. Even NC is not there. And at least ping is there, no? Even ping is not there. What is happening? How do I do my troubleshooting? Even ns lookup command is not there. You are clearly getting the problem I'm highlighting. This pod was supposed to run my application. It was not a specialized pod for doing networking troubleshooting. Correct? So I should not be expecting these utilities which are specialized for troubleshooting the networking problems be available in this application. Because as a DevOps engineer, it's my responsibility to keep the image small as possible, right? So if I'm adding a few binaries for the networking troubleshooting, few other binaries, and make 10 GB of the image, then that's not good, right? It's not that every day, every minute we will need these utilities. So that's why it's not good idea to bundle them in this application. Now, what is the way forward then? Point is clear. Bundling the debugging tools into the production application image is not a good idea. But I need those tools, right? How do I do troubleshooting otherwise? I have become blind right now. I don't know what is going on. Well, don't you worry at all. Come out of this pod, do an exit, and in case you are wondering, now the hostname will change. Okay? Come out of it first, and we want to explore a magic. Its name is Netshoot. Netshoot is simply a container packed with network debugging tools. The key idea is this: debug the network from the same place where the application lives. So we will run the Netshoot application pod in the same namespace where our application is running. So remember this command, okay? This is the command that we will use to run the Netshoot pod. What essentially we are doing here is, this is the namespace that we have specified. We want to run a pod. The name of the pod is going to be Netshoot. We do not mind it getting removed once the session is over. Again, we want the interactive terminal to this pod. Image that we want to use for this pod is Netshoot. We do not want it to be restarted, and we readily want the bash terminal for this. Let's hit enter. For the first time it will take some time because it is performing the download operation of this image. It's not very bulky, but few seconds it can take. Yeah. And there we go. It took about 6 seconds. Okay. And there we are. So I have got a session where curl, ping, telnet, all of these commands are available, right? I can readily make use of these tools to troubleshoot my networking connectivity, right? Let me clear it. And what is that we want to do right now is, from our application, where are we trying to reach? What is the DB host we have specified? It is this, right? DB host. So DB backend. This is what we are trying to reach. do a NS lookup to this and see whether it is server can't find DB backend NX domain. This immediately tells us something important. Kubernetes cannot resolve this service name from this namespace. This is not a bad conclusion. Why? See, in the beginning itself, we made it very clear. DB will live in a separate namespace and application will live in a separate namespace. Now, where is our backend service? It is in black hole DB namespace. And where is our application running? In black hole app namespace. So basically we are trying to go from one namespace to another one. Whenever we do this, we must add the namespace also. NS lookup DB backend dot, along with the service we must also use the namespace to guide Kubernetes where exactly is our service running, right? So now NS lookup DB backend black hole DB. So this is the service name, this is the namespace. Hit enter, and this time you do not see the failure because it is working perfectly fine. While we have tried to hit this service name dot namespace only, but in the backend Kubernetes automatically append dot service dot cluster dot local, this one, okay? So if you try to hit this one also, it's actually good. Okay, NS lookup, this one. So it's basically the same command that you are hitting. What is the point of this exercise? Well, there's nothing breaking as such. DB is fine, application is fine. It's just the application is trying to reach the database with the wrong endpoint, which needs to be corrected. Alright? Our service name is wrong. So what is that we will do? Well, just we need to correct the DB host. What is the correction? Just make this one and put it here, db backend dot black hole db. If you specify the full name also, it's no problem. Okay, it's good enough. In order to keep it very simple and small, I'll just go ahead with this. Let me exit the Netshoot for the time being. Okay, thank you Netshoot, you really helped us in identifying the issue. I'll exit you and apply the Kubernetes manifest one more time. Save it, apply. Okay, go here and refresh. Okay, it is still red, but you can clearly see the error message is changed. Earlier it has problem with the DNS. Now it is saying connection to server at DB backend hello over port number 5432 fail. Connection refused, the server is running on the port. Okay, so it is surely able to reach the service. Then it has got some problem. The connection is not succeeding, but the fix that we have applied is definitely needed because the error with DNS is definitely fixed. Yeah, this is good. Okay, we are very close. So basically we need to fix this issue. So there is again network troubleshooting involved, and for this we will again need the Netshoot port. I'll not give that story one more time. You understand it very well now. Yeah. Okay, I'm in the Netshoot port. Where is that we are trying to reach? This particular thing. And over what port? Over port 5432. Yeah, as the browser says it, right? Let's use Netcat or NC utility for this. So this is the command that I'll execute here. NC-ZB, the DB backend and namespace and the port number. And it clearly says the connection is refused, right? So over port 5432, there is no connectivity. You would say, now immediate question could be that earlier we confirmed connectivity to this and now you are saying it is not connecting. What is going on? Well, earlier we checked whether there is connectivity presence, right? There is at least a connectivity possible. The target service is present and responding to the ping. That did not confirm that every single port that we want to connect is also listening and responding. And here this is more specialized. We want to do over port 5432 the connectivity is available or no. Now you can ask another valid question, that then why we even tried the previous command? We can simply try whether the connectivity is available or 543 over port 5432 or no. Well, you can do that. Well, there are a couple of reasons for this. Firstly, we are checking the port connectivity after establishing the fact that at least IP ping and ICMP test is working. That's one thing. So we can very well check whether a particular port is allowed or no. Right? There's no point in doing it with if the connectivity itself is not there. So at this point, DNS is resolved, but TCP connection is not possible. That's the thing. Let me also try with Telnet. Same thing again. Okay. So in case you are not comfortable with Netcat, there is another utility for it. 5432 connection refused, right? So this is pretty much the same command that we did in our local, right? Using PowerShell, Test-NetConnection, the endpoint, and then the port number. It's the same thing we are doing. It's just that now we are doing in a Linux-based container where our application is hosted, right? That's all the difference is. Okay, it's very clear the port is not listening and TCP connection is failing, yeah? Now the inference of this exercise is we know that DB pod exists as well. This is somewhere service to pod mapping is broken for the database service, right? So let's go to the database and this is DB backend deployment. Okay. The database is exposed over port number 5432. This is all good. Okay. I think port number is fine. So somewhere service to pod mapping is broken. Then what else it is? Let me check the Kubernetes service one more time. Sorry, little confused here. Netshoot job is done. I'll exit it. What I should do is I'll go to Kubernetes database namespace kubectl -n and get svc. This is the service. We'll describe it. So describe service. Do you see what I'm saying? The service is there, everything is good, but it is not having any endpoint. Means this service is not good enough to send traffic to its backend pod. Why is that? Well, there's majorly one condition in which it almost always happen is your label selectors are not correct. So here selector is app db. Okay. What is the pod labels then? So pod app database. That's the problem, right? So here we have mentioned it is database. Here it is DB. For a human being, it may be the same thing, but for the application, it is a big problem, right? It was not able to identify the correct application to which it has to send the traffic for this reason. Let's fix this and apply it one more time. And there we go. Now, after applying this fix, when we have described the service one more time, endpoint is added, which is a good news. Let's go to the browser again and refresh the application. No luck, nothing happened till now. UI is still red, but let's see if Netshoot has got some more information for us, because surely what we have done, we have made some progress. I'll do telnet over port 5432 one more time. No luck here, it's same. Surely things are bad still, but you have to realize that earlier the service that we were trying to reach had no backend. Traffic was not even going to the correct database. I have no problem in admitting that we are still in bad shape, but what you must realize is that until we had made this fix, the service was not even sending the traffic to correct database pod, right? Now surely it is going to the correct database pod. There is some pod behind the service. This is proved by describing the service, and the moment we have seen the endpoint, this is established. But that doesn't mean that there is nothing wrong beyond this service. So what we will do, instead of hitting the service, now we will try to hit the database directly. So this is database, this is the IP, correct? Take this IP and go to the Netshoot one more time, right? So this is my Netshoot port. I'll go inside it and I try to telnet to this. Clear telnet 5432 Postgres database port. And it says it cannot connect. What is that establishes? We are not able to reach the database over the service. We are not able to reach the database directly. Means there is something wrong at the database layer itself. It's not the connectivity, it's something that database itself is not letting this port 5432 getting responded correctly, right? So I have isolated the issue. Now I know that there is something wrong inside this deployment itself. What is that? Look at this closely. If you don't mind, I'll want to do one thing. Git PO. Can I see the logs of this pod also? Maybe something is captured over there. So surely database is ready to take connections, but still somehow connections are not getting established. So we need to see at what are the different parameters that we have set for this application. This is the image. It is used by thousands, so there is nothing wrong in the image. Port is fine. There's some password. It could be anything. So there is no problem here also. I could clearly see there is one problem now. So we are sending these arguments Postgres -c listen addresses localhost, means if the connections are coming from the local host, then only it will take, otherwise it won't. That is a problem. So even if the connection reached the database to the Postgres, it will be rejected because it did not come from the local host. Kind of we have established a security around this, which need to be softened because we are coming from a different namespace. Our application is hosted in a different namespace where traffic is sending from there. It's surely not the local host. So how do we allow the traffic coming from our application? Maybe the easiest thing that we can do is allow all traffic. And this will whitelist the traffic coming from our application as well. This is the simplest fix that we can apply. I do not want to extend this lecture too long. So, okay, this is the fix. I have applied the YAML. Let's go to the browser again and refresh. And there we go. It's all green. My application is able to reach the database. It's all green and beautiful. It may look so straightforward, but under the hood, so many things are happening. We are firstly trying to reach the application service over port 80, which is sending the traffic to port 8000 on this pod, right? Which is our application pod. There we try to connect to the database over this host and port number 5432. We go all the way to a different namespace, this service, and then reach the database over port 5432, where we have allowed all the addresses, and that's why we are able to connect to the database, and that's why this button has become green. And this green button says loud and clear that this connectivity is working perfectly fine. It's all smoothened now. I do not want to claim that you have not done something similar earlier, right? You would have hosted an application along with the database, and I'm sure you would have hosted far more complex applications than this. But in many cases, we all try to take the things magically, right? We know that, okay, connectivity happens and we do not go that route. But now what we have achieved in this lecture is we understand that nothing is magical. It's all we have defined the things to work in certain way, and that is why they are working. This brings control and this brings confidence in the DevOps engineer. And this is what separates a good DevOps engineer from average ones. Yeah. In this lecture, we learned how to read the symptoms before touching configuration, use NS lookup, NC, Telnet, not from the application pod, but from a specialized Netshoot pod, which is meant for this kind of troubleshooting only. And now we are far more confident in debugging Kubernetes the way production demands. Well, this mindset, calm, structured, evidence-driven, is what separates a YAML writer from a DevOps engineer. Congratulations on becoming a good DevOps engineer. That's it for now. Thank you.